Hello, this video is designed for first graders. I'm Mr. LaBeouf and I teach grades 5 through 8. I've made dozens of videos for those grades. This is my first venture into a lower grade topic, and I've been thinking a lot recently about the addition facts, the single digit addition facts. This video is designed to go through them and to help you get them into your long-term memories. There will be minimal explanation and discussion about these various addition facts and the subtraction facts that go along with them. I will save explanation for that second video that will go along with this one. There are two considerations during this video. What is subtraction and the commutative property of addition? We will mention those briefly, but for the most part, we're going to go through the facts and encourage you to get them into your long-term memories. So I strongly recommend that you write out everything that I write on the board and perhaps say each sentence, because they are sentences, math sentences, either along with me or right after me. We'll start with the highest sum you can get when adding two single-digit numbers. The number 9 is the highest single-digit number. To go higher than 9, you have to go to 10, which is 2 digits, a 1 and a 0. So the good news is we're starting with the hardest ones and working down toward the easier ones. 9 plus 9 is 18. 18 minus 9 is what? Now, here's where the definition of subtraction comes in. What is subtraction? Subtraction is a question about addition. What we're being asked here is, what number can we add to 9 to get 18? Well, of course, it's right up there. The answer is 9. I'm going to repeat it again. A subtraction is a question about addition. And we can use the word because. 18 minus 9 is 9, because 9 plus 9 is 18. Okay. Nine plus 8. We're going through this in a systematic way from biggest all the way down to smallest. 9 plus 8 is 17. Now here's where something comes into play called the commutative property of addition. The commutative property of addition says it doesn't matter what order you add numbers in. So that 8 plus 9 is also 17. If you know 9 plus 8, you know 8 plus 9. The commutative property of addition. The order that we add the numbers in does not matter. How about this? 17 minus 9. Okay? This is a subtraction. It is a question about addition. This is asking us, what can we add to 9 to make 17? And of course, it's 8. It's right up above in both of those additions. And the fourth and final sentence that we can write and say for these two numbers, 9 and 8, is 17 minus 8 is 9. Why is 17 minus 8 equal to 9? Because 9 plus 8 is 17. This is often called a fact family. And if you know one of them, you know all four. Say it with me. Write it for yourself. 9 plus 7 equals 16. We instantly know that 7 plus 9 is also 16. And we have two subtraction facts. 16 minus 9 equals 7. Because 7 plus 9 is 16. And we also have 16 minus 7 equaling 9. Why? Because 9 plus 7 is 16. A fact family. Next we have 9 plus 6, which is 15. And if 9 plus 6 is 15, of course, 6 plus 9 is also 15. And if we take that 15 and subtract 9, we will have 6. Why is 15 minus 9 6? Because 6 plus 9 is 15. You see the, the reason right above. And 15 minus 6 equals 9, because 9 plus 6 is 15. Next, we'll do 9 plus 5. And you may, because I'm approaching this systematically, I'm leaving the 9 here, and the second number is just going down by 1. So the sums are going down by 1. That's a little bit of an explanation, which I said I was going to save for the next video, but it's hard for me to resist talking about why things are the way they are. There's definitely a pattern to the way I'm doing this. 9 plus 5 is 14. 5 plus 9 is also 14. We take the 14, we can subtract 9 to get 5, or we can subtract 5 to get 9. Another fact family. You should associate in terms of addition and subtraction. The numbers 9, 5, and 14 are connected. Sometimes, you know, one brief little detour we'll take. The next one we're going to do up there is 9 plus 4. But I just want to share a little strategy for learning the addition and subtraction facts that I came across years ago. This is probably used by many teachers today. You form a triangle. You could cut them out of paper, or you could just draw them on paper. And what you do is you put, this is from before, say put the two numbers down here that are being added, the 5 and the 9. You put the 14 up here. And then you put a plus sign and a minus sign in there. What this does is it allows you, once you understand that the fact family has those 4 facts that were up there before, it allows you to see the connection between, with addition and subtraction between the 5, the 9, and the 14. They go together. 5 plus 9 is 14. Go the other way. 14 minus 9 is 5. 14 minus 5 is 9. This is a nice way to not have to write the four facts out there. This just shows you that 5, 9, and 14 are a family, or they're connected with each other in terms of addition and subtraction. 9 plus 4 is 13. Addition is commutative, so 4 plus 9 is also 13. We can take the 13 minus 9. This is asking us the question, what can we add to 9 to get 13? And of course, it's right above. It's 4, and 13 minus 4 is 9. 9 plus 3 is 12. 3 plus 9 is also 12. 12 minus 9 equals 3, because 3 plus 9 is 12, and 12 minus 3 is 9. So there's another fact family. And one of the challenges I have here is I'm not sure what speed I should go at. If you're taking the advice of writing these out for yourself, maybe I'm going a little too fast, but I don't want to take too long. Use the pause button as necessary. 9 plus 2 is 11. 2 plus 9 is also 11. 11 minus 9 equals, or is 2. 11 minus 2 equals 9. 9 plus 1 is 10. 1 plus 9 is also 10. 10 minus 9 is 1. And 10 minus 1 is 9. And I want to say something at this point about adding 1 to a number. Addition is a very straightforward, understandable extension of counting. It's just an extension of counting, and that is obvious here. Whenever you add 1 to a number, you get the next number, right? 9 plus 1 is 10. If you were counting 1, 2, 3, all the way up to 9, the next number would be 10. 9 plus 1 is 10. Let's say you see it this way, 1 plus 9. Well, you don't have to start at 1 and then count 9 more. If you start at 1 and count 9 more numbers, you'll get to 10. But addition is commutative, so why not realize that 1 plus 9 is 9 plus 1? So the sum, or the answer, is 1 bigger than the 9. It's the next number, 10. We will look at 9 plus 0, and then I'll say a bit. 9 plus 0 is 9. 0 plus 9 is also 9. Addition is commutative. 9 minus 9 is 0. And 9 minus 0 is 9. Once again, please notice how the definition of subtraction still applies here. With 9 minus 9, you're being asked, what can I add to 9 to get 9? And the answer is 0. And with 9 minus 0, you're being asked, what can I add to 0 to get 9? And the answer is 9. Now, what do you suppose? Let's just try this little experiment. What if $1,219? I just picked that number at random. 1,219 plus 0. What do you think that is? 1,219. If you add 0 to a number, you get the same number. If somebody has $1,219 and then somebody else makes them a gift of $0, here's $0. I don't see them. You add nothing to 1,219 and you'll still be 1,219. I've made this example because we're not going to include 0 anymore. We're going to realize that if you add 0 to any number, you get the number, the other number, including if you have 0 plus 0. If you add 0 to 0, you're still going to have that 0 you began with. When I teach my middle school students, we learn that letters can take the place of numbers. So let's just say that this letter A stands for any number. This is a number. It can be any number whatsoever. It could be 1,219, it could be 6, it could be anything. If you add 0 to any number, you will get that number. In this set of facts, we're going to begin with an 8 over here. And I have not done 8 plus 9, because we already did that. 8 plus 9 was already part of adding with 9. It was the second one. See, the second thing we did, 9 plus 8 is 17. Then, right underneath it, I wrote 8 plus 9 is also 17 because of the commutative property of addition. So I don't have to do 8 plus 9 here. We'll begin with 8 plus 8. 8 plus 8 is 16. 16 minus 8 is 8 because 8 plus 8 is 16. When you add a number to itself, the commutative property of addition doesn't really apply. When we just did 8 plus 8, and earlier when we did 9 plus 9, if you reverse the order, you still have the same thing. So when you're adding a number to itself, you only have 2 facts. You have the addition fact, and then one addition fact, and then the one subtraction fact. Okay? But now we're back to having 2 different numbers, so we're going to have 4 facts. Once you know that 8 plus 7 is 15, you know 3 other facts. You know that 7 plus 8 is 15, and you know that 15 minus 8 is 7, Why? Because 7 plus 8 is 15. It's right here. And you also know that 15 minus 7 is 8. Because 8 plus 7 is 15, and it's right there. 8 plus 6 is 14. 6 plus 8 is also 14, because addition is commutative. 14 minus 8 equals what? Well, what do you add to 8 to get 14? The answer is 6. And 14 minus 6 is 8. 8 plus 5 is 13. 5 plus 8 is also 13. 13 minus 8 is 5. And 13 minus 5 is 8. A fact family. 5, 8, and 13 are connected with each other for addition and subtraction. You need to get into your long-term memories that those numbers go together. 5, 8, and 13 in terms of addition and subtraction. 8 plus 4 is 12. 4 plus 8 is also 12. 12 minus 8 is 4. And 12 minus 4 is 8. 8 plus 3 is 11. 3 plus 8 is also 11. 11 minus 8 is 3. And 11 minus 3 is 8. I'm having trouble with markers that they don't last very long. I'm going to get another one soon that you can see better. 8 plus 3 is 11. 3 plus 8 is 11. 11 minus 8 is 3. And 11 minus 3 is 8. I have a brand new marker. Let's see how long it lasts. 8 plus 2 is 10. 2 plus 8, also 10. 10 minus 8 is 2, because 2 plus 8 is 10. And 10 minus 2 is 8, because 8 plus 2 is 10. And now we're back to adding 1 to a number. When you add 1 to a number, you get the next number. It's an extension of counting. 8 plus 1 is 9. 1 plus 8 is also 9. So when you encounter this one, it might be easier to think of it this way initially, and then eventually, of course, it'll become automatic. 9 minus 8 is 1, because 1 plus 8 is 9. You can sort of add backwards. 1 plus 8 gives you this 9 when you're subtracting. Subtraction is a question about addition. 9 minus 1 is 8, because you look at it sort of backwards. 8 plus 1 gives you the 9. And we're not going to do 8 plus 0. A number plus 0 is the number. 8 plus 0 is 8. And, all the other elements of that fact family are pretty straightforward. Notice I did not put 7 plus 8 or 7 plus 9. This first number, the rest of the way through this next set is going to be 7 here. But we already did 7 plus 9 and 7 plus 8 earlier. Addition is commutative, so there'll be fewer and fewer facts to learn as we go forward. 7 plus 7 is 14. And the commutative property doesn't really apply here. If we reverse the order, we still have 7 plus 7. And there's just the one subtraction fact. That's 14 minus 7 is 7, because 7 plus 7 is 14. 7 plus 6 is 13. 6 plus 7 is also 13. 13 minus 7 is 6. And 13 minus 6 is 7. 7, 6, and 13 are connected with each other for addition and subtraction. 7 plus 5 is 12. 5 plus 7 is also 12. 12 minus 7 is 5. And 12 minus 5 is 7. Seven plus 4 equals or is 11. 4 plus 7 is also 11. 11 minus 7 is 4 because 4 plus 7 is 11. 11 minus 4 is 7 because 7 plus 4 is 11. Subtraction is a question about addition. It's really not something totally different to learn. If you know this, you know all 4 facts. 7 plus 3 equals 10. 3 plus 7 is also 10. 10 minus 7 is 3, and 10 minus 3 is 7. Seven plus 2 is 9. 2 plus 7 is also 9. 9 minus 7 is 2, and 9 minus 2, surprise, not really, it's 7. Just a quick word about the connection between the English language and math. What's 1 more than 7? It's very easy, isn't it? 1 more than 7 is 8. Well, that's what this says. The plus 1 can be thought of as 1 more than. 7 plus 1 more, or 1 more than 7 is, of course, 8. 1 plus 7. Now, if this is 1 more than 7, this is 7 more than 1. This is easier, right? 1 more than 7 is obviously 8. But this here, because of the commutative property, is also 8. 8 minus 7 is 1. And 8 minus 1 is 7. We're not doing 0, remember? So we're done with 7. We're going to move on to 6. I'm going to take this opportunity, ladies and gentlemen, to preview the other video that goes along with this one. 6 plus 6 is 12. A very short time ago, we saw this. Some of these single-digit additions, or the facts that I'm strongly urging you to learn so well that it's right here forever. And you can always know that 7 plus 5 is 12, 6 plus 6 is 12 immediately. But we can get into some why questions, which we will do in the other video. It should make sense to you that these two additions have the same answer, or by the way, sum, another word I might as well introduce you to. The sum of two numbers is you add them together. So the sum of 7 and 5 is 12, and the sum of 6 and 6 is also 12. Notice it's not this sum, like I have some apples. No, it's S-U-M, and that's one of the vocabulary words from math. There are very few vocabulary words in math, by the way, but the ones we have are important. Now, this should make sense to you because this 7 is 1 more than that 6, and this 5 is 1 less than that 6. So they kind of balance out. Does that make sense? The 7 is 1 more than the 6. But this 5 is 1 less than that 6. That's why. We'll maybe in the other video, we're not going to look at all the possible facts or numbers that you could add, but we'll give you enough of a sense to reason through situations like this to understand the underlying reasons why some of these facts are what they are. So 6 plus 6 is 12. And 12 minus 6 is 6. 6 plus 5 is 11. 5 plus 6 is also 11. 11 minus 6 is 5, and 11 minus 5 is, of course, 6. 6 plus 4 is 10. 4 plus 6 is also 10. 10 minus 6 is 4, and 10 minus 4 is 6. 6 plus 3 is 9. 3 plus 6 is also 9. 9 minus 6 is 3. And 9 minus 3 is 6. 6 plus 2 is 8. 2 plus 6 is also 8. 8 minus 6 is 2. And 8 minus 2 is 6. What is 1 more than 6? 6 plus 1 is 7. 1 plus 6 is also 7. 7 minus 6 is 1. And 7 minus 1 is 6. We're getting there, first graders. We're down to 5s. And of course, there are, as I said before, there are fewer facts in each set, because we've already covered 5 plus 6, 5 plus 7, 5 plus 8, and 5 plus 9. Just a reminder up there that I skipped 6 plus 0 earlier. Well, a number plus 0 is the number. This A stands for any number. Any number plus 0 is the number. Also, if you subtract 0 from a number, you also get the number. So, before, when I skipped 0 from 6, this A could be 6. 6 plus 0 equals 6. The A here, both 6. So there's the statement. Subtraction works in a similar way. If you subtract 0 from any number, you get that number. So again, if each A is 6, you have 6 minus 0 equals 6. Just a reminder. 5 plus 5 is, of course, 10. Now, you talk about wise and understanding, deep understanding. 5 plus 5. 5 digits on this hand, 5 on the other, 10 altogether. You've known that for a very long time. And by the way, these are called digits. How many fingers do I have? Well, technically only 4 on this hand, and this is a thumb, it's not a finger. But we have this general name for fingers or thumbs called digits. And that's what we call things like 5 and 0 and 1 and 6. Remember, we're doing the single digit additions. Do you think it's a coincidence that the same word digit is used for the 5, the 1, the 0, the 6, the 7, the 8? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the 10 digits that our number system works on. And we have 10 digits. Yeah, that's not a coincidence. Not a coincidence. That they're the same. Because, you know, we all, at some degree, probably every human being learns to count or starts to get an understanding of numbers from these digits on our hands. 5 plus 5 is 10. 10 minus 5 equals 5. The way I'm doing this, ladies and gentlemen, kind of working backwards from 9 plus 9, when we got to 5 plus 5 just now being 10, that was the last time that we're going to have a sum or an answer over here that has 2 digits. The rest of the way, the numbers are getting smaller. 5 plus 5, that was the last time that we're going to see a 2-digit answer over here. 5 plus 4 is 9. You'll see. And it should make sense to you that we will never get, the way I'm doing it, making the numbers get smaller. It should make sense to you that we're not going to get any 2-digit number over here. Everything over here is going to be less than 10 now. 5 plus 5, the way I'm doing it, was the last one where the answer had the 2 digits. 4 plus 5 is also 9. 9 minus 5 is 4. And 9 minus 4 is 5. 5 plus 3, 8. 3 plus 5, also 8. 8 minus 5. What do you add to 5 to get 8? Of course, it's 3. 8 minus 3 equals what? What do you add to 3 to get 8? Of course, it's 5. 3, 5, and 8 are connected with each other for addition and subtraction. 5 plus 2 is 7. 2 plus 5 is 7. 7 minus 5 is 2. And 7 minus 2 is 5. 1 more than 5, or 5 plus 1 is 6. 1 plus 5 is also 6. 6 minus 5 is 1, and 6 minus 1 is 5. We're ready to move on to the 4s, and we're getting close to the end. 4 plus 4 is 8. 8 minus 4 is 4. Save a little time here for myself, and we'll go to 4 plus 3, which is 7. 3 plus 4 is also 7. 7 minus 4 is 3. And 7 minus 3 is 4. You can just barely see all of those, right? Yes. All right. Time to move on to 4 plus 2. 4 plus 2 is 6. 2 plus 4 is also 6 because addition is commutative. 6 minus 4 is 2 because 2 plus 4 is 6. And 6 minus 2 equals 4 because 4 plus 2 is 6. 4 plus 1 is 5. 1 plus 4, also 5. 5 minus 4 is 1, and 5 minus 1 is 4. 3 plus 3 is 6. 6 minus 3 is 3, and that's it. I didn't mean it, that's it entirely. That was just it. Only 2 facts because we have the same number being added to itself. 3 plus 2, of course, 5. Well, there's the little kids. Little kids look at 3 and 2. You can do that with 4 and 1 as well. You know, the digits. 3 plus 2 is 5. 2 plus 3 is also 5. 5 minus 3 is 2. And 5 minus 2 is 3. I think I can fit all the rest of them, all the rest, in the board at one time. There aren't very many. We're almost there. 3 plus 1 is 4. 1 plus 3 is also 4. 4 minus 3 is 1, and 4 minus 1 is 3. And of course, we're not bothering with 0. 3 plus 0 is 3. So we're done with 3. So that only leaves 2. And we have 2 plus 2 equaling 4. Is that right? We're done. We're really that close then. 4 minus 2 equals 2. The only thing left, because we're just treating 0 with that general rule. All right? Learning general rules like that is an important part of math. So I wrote it up here. And it's not often that teachers present letters to students. My middle school students use letters all the time to stand for numbers, but I don't think it's too early for you to just have a little glimpse about this fact that in mathematics, we increasingly, as you get older, you'll see letters taking the place of numbers. Any number plus 0 is that same number. A plus 0 is not B. It's not B. Because when we use letters, the assumption is this A and this A are the same number. Because they're both A. So, we did 2 plus 2. Now, the only thing left is 2 plus 1 is 3. And 1 plus 2 is 3. 3 minus 2 is 1. And 3 minus 1 is 2. I guess that's not the end. We're treating zeros separately because of this rule that we've talked about a few times. But I guess there's one more. I thought when we went through the 2's would be done. But there is just one more, ladies and gentlemen. Wait for it. This is going to be a hard one. 1 plus 1 equals 2. And of course, there is a subtraction that goes along with that. 2 minus 1 equals 1. You've journeyed with me all the way from 9 plus 9, all the way down to 1 plus 1, and 37 minutes, I can see. That's how long it's been. It's worth it. Putting in a little time when you're young, putting in enough time to get where you need to be, day by day, week by week in first grade, and then do it again in second grade, and continue. A little bit of effort each day. Do what you need to do. It's going to be different for everybody else. Some people will need more time to master these facts than others. That's okay. No teacher expects you to be like anybody else. You are you. But we want you to be the best that you can be at all the things that we present to you in school. And in particular with math, I always believe every student can learn math at a high level. Please put in the work that's necessary. Depend on your parents. Seek out their guidance and ask questions of them about math. They'll probably enjoy discussing math with you because they want to see you grow as well. And ask your teacher when something is unclear. Very often the teacher can clear up that problem right away and you'll say something like, "Oh, now I get it." Have those moments. Look forward to those moments to enjoy them when you get it. Math is beautiful and it's wonderful, and I want you to have a wonderful experience with it throughout your lives. So long for now.